my channel. So let's continue with the part 2 of the chemistry of the elements. So in this part 2, we are going to construct the electron configuration. This is what we or I have shown to you how to write down the electron configuration for an atom. Okay, right. So as here in this slide, we have the electron configuration of cation and also anions. So what is cations and what is anions? So as you know, cations is actually a positive charge, and anions are actually a negative charge. So how to actually write the electron configuration for cations and also anions? So let me show you. Alright. So for the first one, here, we have examples of cations. So these atoms, or these cations actually lose, or first one, before they become cations and anion, they lose or they gain electrons. Here we have cation, so the atoms lose electrons, so that cation has what we call stable noble gas outer electron configuration. For example, here, first one, we have sodium with 11 electron here, or 11 proton number. So what happened here, the electron configuration that you need to write it down as neon 3s1, and then after that, this sodium has tendency to remove, or to lose one electron from here. So what happened here, it will give you the neon, right? And then another example, we have calcium. The electron configuration is Ar4s2. So, and then this calcium has tendency to remove 2 electrons from itself, so it will become calcium 2 plus. It will become from the calcium, it will become calcium 2 plus, and then the electron configuration here will become Ar. Ar equals to 18 electron. Alright, and then other than that, we have aluminium. So the electron configuration here is Ne 3s2 3p1, and as you know, aluminium has tendency to remove 3 electrons from the 3s2 and 3p1, so it will give the new electron configuration for aluminium 3 plus as neon. So this is for cation. And then another one, we have anion here. So we have anions. So anions has tendency to gain electrons. So this so that anion has a stable noble gas outer electron configuration. So both of these need to form a stable noble gas outer electron configuration here, right? So for cation, they lose electron, while for the anions, they gain electrons. Let's look at one example for anion. So here I have a fluorine, and then with 9 proton number or 9 electron here. So the electron configuration will be 1s2, 2s2, and 2p5. So because this fluorine has tendency to receive or to gain 1 electron. Why? Because this is 2p5. So in order to form a noble gas electron configuration, it actually needs to receive 1 electron here. And then after receive 1 electron, it will become 1s2, 2s2, 2p6, or known as the neon here. The same goes to, for example, we have nitrogen. Nitrogen here, we have 2, 4, 7. Nitrogen 7, 1s2, 2s2, 2p3. And then because this nitrogen want to actually want to form a noble gas electron configuration, it needs to receive 3 electrons here. So it will become 1s2, 2s2, 2p6. And because it actually received 3 electrons, so it will become n3 minus. Okay. While for the fluorine here, it received 1 electron here, it will become F minus or F negative 1. Okay. Alright. Then here, this is actually cations and also anion representative element. So you can refer this one, okay? But you do not need to remember because from the from the periodic table itself, you can write your or you can write the electron configuration for each atom, okay, based on the 3 principles, all right? Aufbau, Hans rule, and also Pauli exclusion. All right. Then this is positive 1, this is positive 2, this is positive 3 because they lose 3 electron, and then negative 1. Okay, group 17 is negative 1 because they receive 1 electron. Okay, and then group 16 negative 2 receive 2 electrons. All right. And then group 15 receive 3 electrons. For example, like I have shown to you before this, nitrogen. Okay. And then, yeah, that's all for the cations and anions. And then we go to the isoelectronic. So what do you know about isoelectronic? Iso means similar or same. Okay. Iso is same. Okay, so for isoelectronic means that two anion or cation can have the same electron configuration. Okay, so they have the same number of electrons and also electron configuration. For example, here I have this is sodium plus and aluminium 3 plus. They have both same electron configuration and same number of electrons. Okay, and then other than that, I have here fluoride. This is fluoride because it receives 1 electron. And then we have oxide here and nitride here, okay, and 3 minus. So all these 3 anions have same number of electrons and also same electron configuration, as you can see here. Okay, here 1s2, 2s2, 2p6, or known as neon. So I have one quiz here. All right, so what neutral atom is isoelectronic with hydrogen minus, or we call it as hydride? So this one we will be discussing this question during our virtual class. Okay, right? So, okay, from these cations and also anions here, all of these 5 anions and also cations are isoelectronic with neon. Okay, right. Then here, other than that, we go to the electron configuration of cations of transition metals. Okay, so in this one, this is where we are dealing with the d orbital. Okay, all right. So for example here, okay, all right, before that, how to write down the electron configuration for the transition metals? Okay, so when a cation is formed from an atom of transition metal, so the electrons are always removed first from the s orbitals, okay, and then from the n-1d orbitals. Why? Okay, why? Because do you still remember the Aufbau principle? Okay, we need to write down the 4s first, okay, and then followed by the 3d. Okay, right? So this is actually based on the Aufbau principle. Okay, all right. So here, let's say we have here iron, okay? Iron, this is 18, 26, okay? Iron, we have 26. So you write it down as Ar4s2 3d6, okay? Ar4s2 3d6, right? Based from the Aufbau principle. And then let's say this iron, okay? And then this iron remove 2 electrons from, okay, from itself, okay? So it will become, okay, Ar4s0 3d6, or you can write it down as Ar3d6, okay? So you need to remove these 2 electrons from the outermost orbital, which is 4s, okay, which is 4s here. So it will give you as Ar3d6. Why? Because let's say we have, this is 3p, this is, okay, this is 3p orbitals, okay, and then we have the 3, after 3p is the 3d, and then followed by the 4s, right? Okay, this is how we arrange the atomic orbital, okay? Alright, so from, you need to remove electron from the outermost orbital. So now, because we want to remove 2 electrons, so we remove, start from the 4s. This is the outermost electron. Sorry, outermost orbital. Okay, alright. So remove 2 electron and it will give you as Ar3d6. Let's say we want to have the iron 3 plus, okay? So you remove from the 4s, 2 electron from the 4s, and 1 electron from the 3d6. So it will give you as Ar3d5, okay? And then this is first example. Other example, we have here manganese 25, okay? So the ground state, okay, ataupun what we call neutral atom, okay, we have the Ar4s2 3d5, okay? Then you need to remove 2 electron if you want to have the manganese 2 plus. So remove from the 4s 2, okay, it will give you as Ar3d5. Alright, and then this is 3d5, okay, here. And then for the manganese 2 plus, the 3d orbital is more stable than the 4s orbitals in transition metals ion. So okay, we have 2 kinds of how to write the electron configuration, first one and also the second one. So this is the correct way to write down the electron configuration. While for this one, 4s2 3d3, okay, you cannot write it down as like this because the 3d orbital is more stable than the 4s orbital. So this is wrong, okay? Right, so start with the outermost electron, outermost orbitals in order to remove the electrons, and then you from the 4s, and then followed by the 3d. Okay, right. So that's all for the part 2 of the chemistry of the elements. So I'll see you guys in part 3. So please don't forget to like, comment and subscribe my channel. I'll see you guys in part 3. Bye.